All right, folks, what we're going to talk about in this set of videos is we're going to talk about what are called the properties of logarithms. So we're in the middle of talking about exponential relationships, and logarithms are a part of exponential relationships. And so it's important for you to understand some basic rules, I guess you could say, or properties of logarithms. Now, these are pretty easy. They're pretty basic. Really, all you have to do is memorize them and practice them a lot, and then they're very, very easy to understand. For the most part, there are three main properties of logarithms that you have to understand. Technically, there's four, but you've already learned one of them, and that's the change of base formula, and we learned that in one of the previous videos. Okay, so what we're going to talk about first is I'm actually going to take each property and I'm going to split it up into two parts. Okay, so the first one is, I call it the addition to multiplication property of logarithms. Okay, the addition to multiplication. Similarly, the same property, only I'm going to call it the opposite. There's the multiplication to addition property. Okay? And basically the idea here is that logarithms turn multiplication into addition. And that's one of the reasons that logarithms are so useful, is because addition is easier than multiplication. I mean, for the most part. I mean, adding 3 plus 4 is a little bit easier than multiplying 3 times 4, but it gets even more complicated when we're dealing with decimals. So adding 2.753 plus 1.629 is easier than multiplying those two decimals. Okay, and so since logarithms turn multiplication into addition, they make things, mathematics, very much easier to use. So this is one of the reasons that logarithms are so awesome. Okay? Now, since logarithms turn multiplication into addition, we can also reverse the process and take the addition of logarithms and turn it into multiplication. Okay? So you can go either direction. So let's start with addition to multiplication. Let's say that we have log base 7 of 4. And this is a number, right? If we were to plug this into the calculator, we would get a number by plugging this in. In fact, if you did log 4 divided by log 7, you would get a number, okay? And it would be less than 1, because 7 to some power to equal 4, that power would have to be less than 1. All right, so let's say that we have log base 7 of 4 plus log base 7 of 5. What would this be equal to? Well, in logarithms, we can take the addition of two logarithms. Now, assuming they have the same base, both of these logarithms are log base 7. If they were not, if this said log base 7 and this said log base 6 or log base 2 or log base 11, there would be nothing we could do. There wouldn't be any kind of simplification. It would be done. It would just have to sit like that. But since these are both log base 7, we can combine what's inside of each log by multiplication. So log base 7 of 4 plus log base 7 of 5 would be equal to log base 7 of 4 times 5. 4 times 5. So the two logarithms turn into one logarithm, and because it was addition, it turns into multiplication of these two numbers. And of course 4 times 5 is 7. So this would be the same thing as log base 7, 4 times 5 is 20. So this would be the same thing as log base 7 of 20. All right, well, let's say instead of, and you might be wondering, well, does that work the same way for the natural log? It sure does, because the natural log is log base e. So if we have the natural log of 10 plus the natural log of 7. Okay, well, what do you think that this would be based on this rule? It's the same base. We're adding, and therefore, what are we going to do with the two inside pieces? We're going to multiply them, right? So this would be the same thing as the natural log of 10 times 7, which would be the natural log of 70. And I can prove this to you. I'm going to grab a calculator. All right. So let's see here. We're going to add the natural log of 10 plus the natural log of 7. All right, so you look at the calculator here. So we'll do natural log of 10, we'll close the parenthesis, plus the natural log of 7, we'll close the parenthesis, we'll press enter. Let's see what we get. We get 4.24849, right? Now let's do the natural log of 70. Let's do the natural log of 70, and we'll press enter, and we get 4.24849, same number. All right, so this just shows that, well, inductively we're showing that it does work. Okay, it's not a deductive proof, but it is proven. This is the truth. Okay, so let's maybe do one more, and I'll let you try and figure it out. What if we have log base 13 of 9 plus log base 13 of 4? What would this be equal to? What do we do with it? What are we going to do with the 9 and the 4? Well, there's addition between the logs, so that means we're going to multiply these, and then it becomes log base 13 of whatever 9 times 4 is, which is 36. So this is the same thing as log base 13 of 36. Now that we know this property, we can also reverse it. We can start with the multiplication and go backwards into addition. So let's say that we had log base 3 of 2 times 5. Well, 2 times 5, that's multiplication inside of the logarithm, so that's going to turn into addition between the logarithms. We have to break this logarithm into 2 separate logarithms and put a plus between them. So it'll become log base 3 of 2 plus log base 3 of 5. And so we've broken the logarithm apart into 2 pieces. What if we had the natural log of 4 times 9? Okay, well, that's multiplication. It's going to turn into addition. We need to break it into 2 logarithms. So it'll become the natural log of 4 plus the natural log of 9. What if I had log base 2 of 15? Log base 2, well, this is only one number. It's just 15, so I can't do anything with it, right? Wrong. What can 15 be broken up into? Can we break that up into 2 numbers that are multiplied by each other? Is 15 equal to the product of 2 numbers? It sure is. 15 is equal to 3 times 5. So we could rewrite this as log base 2 of 3 times 5, and now it's going to become log base 2 of 3 plus log base 2 of 5. And you have to think like that. You have to think creatively like that. You got to think about how to break it apart. What if we had the natural log of 21? Do this one on your own. Go ahead and pause and see if you can break this apart. All right, well, what does 21 break down into? Isn't 21 the same thing as 7 times 3? Isn't that the same thing? 21 is equal to 7 times 3. And now that it's multiplication, we can break it apart into addition. And now it becomes the natural log of 7 plus the natural log of 3. All right, let's do one more. What if I had log base 6? And this is where it starts to become very useful. What if I had log base 6 of 5x? Isn't this multiplication here, this 5x? So we can break this apart into 2 logarithms, one that has a 5 in it and the other one that has an x in it. So this will become log base 6 of 5 plus log base 6 of x. And that's it for the multiplication to addition property of logarithms. So now you can see how to go from addition of logarithms to multiplication inside of one logarithm, or from multiplication inside of one logarithm into the addition of two separate logarithms. That's all I have for this particular video. In the next video, we will do the next property of logarithms.